Hello. In this video, I will show you another available option to load a new mesh in Interface Equilibrator. If you have an input set of 3D points representing a certain surface, you can use Interface Equilibrator to create a triangular mesh from these points. For example, let's consider the set of 3D points shown here. We need to have these 3D points saved on a text file with this format. That is, the X, Y, and Z coordinate values of each point are saved on a different row of this file, separated only by blank spaces. Then, we launch a new configuration in Interface Equilibrator. Say we want to create a new solid surface mesh from these points. Then, we click Add New Solid Surface Mesh, and then we select from an input set of points. Then, we select the text file with the vertex coordinates that I showed you before. And we select Generate Mesh Triangulation from the loaded points. Since these points represent a closed surface, we select Sphere Topology as geometry for the mesh. And then we click Load. A new solid surface mesh has now been created from the input set of 3D points. And I can now use it in Interface Equilibrator. For example, here I simulate a droplet wetting this surface. Instead of a closed surface, the input set of 3D points can also represent a planar surface, like shown here. Then, the procedure to create a new mesh from these points is essentially the same. You select the text file with the 3D coordinates of these points. And then the only difference is that, as mesh geometry, you select planar. Then, we click Load. And the mesh is created from the input points. And we can now use it. And the same procedure can be used also to load fluid interface meshes from input points. When you load an input set of 3D points representing a closed surface, Interface Equilibrator first projects those points on a spherical surface, then uses a stereographic projection to project them on a 2D plane, and finally uses these 2D projections to generate the triangulation. This means that you will be able to triangulate correctly only 3D points on a closed surface that is not too much concave. Analogously, when generating a triangular mesh with a planar geometry, the input 3D points are projected on the X and Y plane. So you will be able to correctly obtain the mesh only for surfaces that do not have overhangs in Z. Alternatively, when you want to create a mesh from an input set of points, you can provide the triangulation as input. Let's consider, for example, this simple mesh. Firstly, if you right-click the mesh node and then click Save, you can save the coordinates of the mesh vertexes by selecting Vertex Coordinates. This will allow you to save a text file with the 3D coordinates of all the mesh vertexes. The format of this file is the same as before. That is, each row represents a different vertex. In addition, when saving the mesh, you can also select Mesh Triangulation. This instead will allow you to save the triangulation of such a mesh on a text file. The file that you obtain contains the list of all the facets of the mesh. Each row corresponds to a different facet, and the 3 integers in each row indicates the 3 vertexes forming that facet, where 1 is the vertex in the first row of the file with the vertex coordinates, 4 is the vertex in the 4th row, and so on. If you want to create a mesh from an input set of points, and you want to provide the mesh triangulation as input, then you can do so by using a file with this format. For example, let's say that we want to create a mesh like the one we have now loaded, but with an additional facet between this vertex, which is the 6th in the list, and this vertex, which is the 5th in the list, and this vertex, which is the 4th in the list. So, to create such a mesh, I need to provide, firstly, this list of vertexes, and then this file with the mesh triangulation, to which we add this additional facet by adding one more row, indicating that such a facet is formed by the vertexes 4, 5, and 6. Let's now first remove the previous mesh. Then, we load a new mesh, selecting from an input set of points, and we select the file with the vertex coordinates list. Then, instead of selecting Generate Mesh Triangulation from Input Points, we select Load Mesh Triangulation from Text File, and we select the text file with the mesh triangulation. Then, by clicking Load, we obtain the same mesh as before, but with the additional facet that we added in the text file with a mesh triangulation. And we can now use it. Lastly, if you want to save the 3D coordinates of only specific vertexes of a mesh, then you can exploit this tool. First, deselect the Select Only One Vertex option. Then, choose from here the mesh from which you want to select the vertexes, and then select the vertexes for which you want to save the coordinates. You can also select multiple vertexes at a time by dragging the mouse. Finally, click the Save Selected Vertexes on File button. This allows you to save a text file with the 3D coordinates of the vertexes that you had selected, which are saved in the format that we saw before. That is, each row corresponds to one of the selected vertexes. Thank you for having followed this video. For more information and for other tutorial videos about Interface Equilibrator, please visit our website.